Thanks for joining everyone today. Today, I'll show you a quick demo of Snowflake Intelligence and how it helps us to close the gap between business questions on the plant floor of a manufacturing company and the data scattered across different systems. So in the end, we want the maintenance teams to get answers fast with natural language and high confidence. I'll quickly outline the problem we face at different manufacturers working with Snowflake, why we think there's a need for an intelligence layer, and then how Snowflake delivers this with Snowflake Intelligence in a quick demo. So first of all, what we see with different organizations is that we have business users on the one side and we have data teams on the other. And business users typically have practical questions, right? Things like what failed, why did it fail, what to do next. The data teams, on the other hand, they sit on the right tools, the right sources, and the right skills. And these are separated by processes, skills, and time. So in the end, as a result, we have this knowledge gap in between. The requests queue up. We get answers too late, critical contexts get lost in translation between business users and the data team. So, and classical dashboarding solutions don't really help us to close this gap. So our goal is to remove this friction and get a tool into the hand of the business users, to the plant operators, to actually ask the questions in natural language on their governed enterprise data. So I would argue that everyone today, probably from an executive to a plant operator to a maintenance engineer, everyone is used to asking questions to a chatable interface to a large language model, be it Grok, Claude, ChatGPT. Everyone uses something similar. So obviously, everyone now expects to get answers in plain language, also grounded in their enterprise data, and not digging through a maze of tickets or dashboards. And I think that's why it's important to have an enterprise intelligent agent that really understands the intent, finds the best resources, and returns a justified response that we can trust. So on the one hand, it makes the things faster. I think that's important. But what's really more important, I think, is the why. Then finding out the why and understanding the why rather than just the what. So having an agent that reasons is crucial. And this is where Snowflake Intelligence comes in. It's a unified AI-powered interface called Snowflake Intelligence. It's powered by large language models. In my case of the demo, it will be Claude, but it could be easily also OpenAI. And behind the scenes, we use Snowflake agents. So the Snowflake agents, they can make multiple calls and they combine them into a single request and response. So basically, they orchestrate different types of services. In my case, it will be two different types of services. It will be first the Cortex Analyst, which is basically text to SQL. So it's made for asking natural language questions to structured data, such as tables, views, and so on. So it gives us a way of asking analytical questions. And the second type of service is the Cortex Search Service, which is a RAG-based approach, helping us to extract information from large unstructured data, such as PDFs. So the first type of data or data source that I'll be using in my demo is the sensor data. So what we usually do here with Snowflake is we ingest live sensor signals right from the lines using, for instance, MQTT, streaming, Kafka streaming, similar ways of getting data into Snowflake. So these could be values such as temperature, vibration, and pressure. In my demo, I'll be ingesting this type of data into Snowflake, building a Snowflake native semantic view on top of it. You can think of the semantic view to help translate the business questions for the agent into the actual SQL query. So it's kind of like a dictionary that helps the agent understand the business intent of the question and translate it to the technical metrics and columns of the data in the database. Also, I trained a model, a Snowflake machine learning function on top of this data. In this case, it's an anomaly detection function, which helps us to identify anomalies such as in the vibration or temperature values, which we can then display in a Streamlit dashboard for the plant operations to identify quickly the outliers. In the end, we'll make Snowflake agent use this data through a Cortex analyst service to help us answer questions to the analytical data of our sensors, such as error rates, outages, high values, outliers, and similar. In the end, sensor data isn't worth much if we can combine it with other information. And that's where, for instance, the OEM manuals come in. So the second data source is unstructured knowledge. So it's large volumes of OEM manuals, such as you can see here on the screens. It's about procedures, error codes, PDFs, basically provided by the OEM manufacturers with the information. We'll be using, in this case, Cortex Search to make this searchable through Snowflake Agent. So it can help us identify the right information, the right sources, and gives the plant operator guidance on official procedures. And lastly, I think this is an underrated source of information. It's probably years of workforce know-how. It's often handwritten reports, incident reports, for instance, or the free text that we find for in ticketing systems such as CMMS systems or work orders. And I think this data is really valuable, but it's often hard to reach when it matters. So this is the third type of data we'll be using in our agent. It's also based on a Cortex Search service. It's using the maintenance data in Snowflake. On the one hand, it's extracting information directly from CMMS systems of free text fields, such as in the information, what was repaired, what's the parts that have been replaced and things like that. And on the other hand, it will be using handwritten reports. Actually, it will be using the same reports that we've been seeing on the screen before let me go one back, on the screen before, like this one. So it's a handwritten report, it's a scan, it's a PDF or an image. And it will be using our Snowflake Document AI, which is an LLM-based OCR tool to actually extract the information from the different fields. So it will be combining those two informations into the maintenance data and also make this searchable via the Cortex Search agent. So in the end, the agent will be orchestrating those different tools or services in order to find the right answer and gives us guidance as a plant operator. So then it comes all together in a plant operations dashboard. So this is a Streamer dashboard, helps us identify the current status of our machines, the past incident reports, things like that, identify outliers of the IoT sensors. And on the other hand, it will be using Snowflake Intelligence. So this will give us a way of asking natural language questions and go beyond just static and basic analytics, asking about the why and gives us guidance. So let's switch over to the demo here. So first, let's start with the Streamer operations dashboard. So we can see we're looking at the last 24 hours here, filtered on 3 different machines. And on the first screen, we can see the anomaly detection. So basically, this is the Snowflake ML function. It is trained on this data, and this gives us information on outliers. So all these diamond shapes basically are identified as outliers on the system. So if we hover over, we can, for instance, see if we go on the bottom with the diamond shapes, for instance, CNC17 has an anomaly detection that gives us an ML score. And we can hover over the rest of them to see that most of them actually go back to the CNC17 anomalies, which we come back to in our Snowflake Intelligence part. Similarly, we could look at past incident reports or maintenance reports, so we can actually draw information from the CMMS systems or from the data we pulled through Document AI. We can see the different technicians, the machines they've been working on, what type of issue there's been, what's the status and what's the cost of this operation if there's been any parts that might have been replaced. And lastly, in a dashboard or an application like this gives us also the option to upload PDFs or images from handwritten reports directly here and feed them back into the pipeline, so allowing Snowflake Intelligence to go and fetch the information again from the uploaded data. So talking about Snowflake Intelligence, let's hop over to this tab here. So this is the interface that I'm being greeted with if I open Snowflake Intelligence. It's pretty simple, it's pretty clean, it's easily usable for any business user. So I'm logged in as John, the plant operations manager. And I want to maybe ask simple questions first. But before we go into that, let's look at these two buttons here. So first of all, this is the factory floor assistant that we're currently using. This is the one that will give us the information for our plant operations. But if I want to ask things about our different printers we have in the offices, I might have a different agent because it's using different data, it's using different OEM manuals, it's not related to anything on the plant operations, so this is a different agent. Also, the agent can use different sources. We've discussed this on the architecture before. In my case, I have 3 different sources. It's the maintenance reports that are coming from the CMMS or handwritten stuff. We have the official manuals from the OEMs, and we have the machine data that is coming in from the live sensors through streaming. I could either select those 2 sources if I want the agent to focus on one of them. For my case, I will leave that at auto select, so the Snowflake agent and Snowflake Intelligence can flexibly decide which is the best one, or if there's multiple ones that we need in order to answer my question. So let's start with a pretty simple one. Let's ask a question more or less deterministic. Which machines do I have in the facilities? Let's start with a simple one. So now it's been completed. Let's collapse the details here so we can actually understand the reasoning of Snowflake Intelligence. So it says the user is asking about the machines we have in the facilities. It understands that this is a straightforward question and it should use the machine data tool. So it's Cortex Analyst. So it queries for all the machines. It gives us an SQL. It's planning the next steps, and it's pretty much providing a table of the answers. So it gives us a list of machine inventories here. And basically, we can also go into the generation details to actually get the information of what type of data Cortex Analyst has been using. So it talks about the data source, which is machine table. It gives us the different columns that's been using. And this is also where the semantic model comes into play, because the technical columns in the database and in the table might not directly relate to the question a business user has. But enough with the simple questions. Let's go into a bit more deeper question and ask about an operational overview. So give it a bit more of flexibility, an open question, and recommendation for quick fixes. And let's see what Snowflake Intelligence does to help us answer this type of question. So as this is more of an open-ended question and a bit more complex, let's look at the details. It's probably also a bit more complex in terms of reasoning. So Snowflake Intelligence understands it first needs to get an operational overview. It uses the sensor data and the maintenance history. Then it searches for the field engineers for quick fixes. And it might also check the official manual. So you can understand, you can see it understands the query. It actually mixes the different sources and lists them in the proper order to actually identify the issues first and then give us guidance on that. So the first thing it does is actually it gives us an SQL query. So it understands what type of information we need in order to get an operational overview. So for instance, it gives us error rates by counting the different errors and so on. So I won't go into detail, but it goes also into the timestamps and the different information about the readings, for instance, and also the manual cost. Then it plans the next steps. So identified similarly to what we've seen in the Streamlit dashboard, the CNC 17 is probably the troublemaker in our plants here. So it also identifies the CNC 17 as the biggest concern with the highest error rate and high maintenance cost, but it also identifies other other machines that might be problematic. And then it understands, okay, how should I represent this? So it goes into critical operations overview, priority for ranking the fixes, and quick fix recommendations. So let's go into that here. So we can see that it first lists the 𝘬𝘁17 as the critical troublemaker with the highest error rate and high maintenance costs. So if we go into the quick fixes, for instance, it tells us we should not replace bearings immediately, which is quite costly, but rather try lubrication first. If we hover over this, we can actually see where it's grounded its guidance here. So this is the actual source. So this is a field maintenance engineer node from probably the CMS ticket. And it gives us information that excessive vibration detected, official procedure, and blah, 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 and so on. So it gives us information on the different fixes that our field engineers did. So in the end, it summarizes that mostly the field engineers find that if we have this type of error, first, we might just need good lubrication, and we could prolong the lifetime of our bearings, but rather replace the bearings only if they stay above a certain threshold. And it does that with similar issues. For instance, just clean the filters before actually repair or replace dirty filters. So in the end, it gives us an immediate action plan. What should we do today? What should we do this week? And it also summarizes this as a cost impact. So we can see it understands the question, it reasons, and gives us information grounded on different sources of the different services of Cortex Analyst and Cortex Search that it pulled together. So we could also go and ask, what if we look at the official procedures? What if we look at the official OEM data? If this looks any different from the quick fixes of the maintenance engineers? So it's completed its thinking. We can see that it actually took multiple of resources. So these are the OEM PDFs into consideration. It gives us the information about, for instance, the 𝘬𝘁17 machine for the error code with the vibration we had before. So it actually says that the official procedure would be replacing the bearing immediately without no exceptions. So we can see that this differs from what the real life experience shows us. And if we go on the bottom here, we can actually see that it understands what we've asked before and finds us the key differences on the OEM manuals and what our field engineers say, and see, for instance, that instead of replacing the bearings, we can actually try lubrications, which will save us a lot of money by doing this. But this isn't something that we can just show in demos. We actually have real-life customers doing similar things with Snowflake today. Wolfspeed, as an example, Wolfspeed is an American developer and manufacturer for semiconductors. So what they had was a pretty similar issue. They faced really long downtimes and slow failure resolutions. And this is partly because they had more than 200 different SQL reporting silos across the business, so talking about analytical data. And then they also said they had 2,000 comments per shift at 3 shifts per day, at years of data of learnings from their field engineers. So, and this was data previously being untapped. So it is pretty similar to, in our demo, to the maintenance reports. And the solution was to unify all the SQL databases into Snowflake together with the information from the maintenance engineers. And then they layered Snowflake Intelligence on top of that to enable natural language questions and answers to the documents and the data, similar to what we did in the demo. In the end, what they ended up with was about, I think, a bit more than 12 production agents. They shared curated models to Snowflake Intelligence, and then they allowed business and operators to use different types of those agents. And in the end, what they ended up with as a result, first of all, as one of the example, they had before executive data effort that took, I think, about a week, cost 10 million, after that became a single Snowflake Intelligence query. So you can see how it accelerates the decision making On the floor itself, the failure resolution dropped about from 2 hours to 2 minutes, and about 98% faster tool recovery by grounding those answers in official knowledge articles. And in short, they built something really similar to what I built in the demo, but at enterprise scale, allowing an AI agent fusing unstructured and structured data together. So in the end, summing up what Snowflake Intelligence does, it allows and supports deep analysis. So the data agents, they don't just retrieve information, they help explain why things happen. They allow you to understand why, and they help you to understand and find what to do next. Then we convert enterprise knowledge into high confidence decisions. You could see in the demo that every answer is transparent. It's traceable back to its source. So it's important to give the confidence into the data to the business users. And then in the end, it's enterprise ready. It's operating within Snowflake's governance parameter, and it's scaling with your data and your complexity. Thank you.